Hello, friends. Here's a little bit of just some overview, basics of work. And I mean work in the sense of energy, right? We're studying energy, energy power, and work. So just some of the basics. The way that we calculate work is force times displacement. But there's a caveat here. Let's say I'm pushing a box, and my force on the box, this is the force of me on the box, and the box is actually going this way, then the work is positive. Okay. So when force and displacement when they're in the same direction, the work is positive. Right. Now, if a cart, let's say it's like a shopping cart, is moving this way, so it has displacement in that direction, and I'm pushing it this way, I'm stopping it. Say it's a heavy shopping cart full of groceries or something. Then in that case, if the force and displacement are in the opposite directions, then the work is negative. This works like positive and negative numbers, right? If force and displacement are both positive, you multiply them together, you get positive. If force and displacement are both negative, you multiply them together, same direction, you get positive. But if one is positive and the other is negative, if they're in opposite directions, like here, then it ends up being negative. Okay. Here's another caveat to this as well. Let's say I'm holding a book. Back to the right color. I'm holding a book. The force on the book is up. This is the force of me. But the book is moving to the right. Delta X is to the right. In that case, these are now perpendicular, and I'm not doing any work on the book. Okay, so if the force and displacement are perpendicular to each other, then the work done is 0. Okay, now here's a little bit of an advanced piece to this. This relationship that we see here is summarized if we change this equation to become work equals F delta X cosine of theta, where theta is the angle between the force and displacement, right? In this situation, theta is 0. So cosine of theta equals 1. In this situation, cos theta is 180 degrees. So cosine of theta is negative 1. And that gives us this, right? In this situation, theta is 90. Cosine of theta is 0. And that gives us this. Okay. And now another basic thing that we need to know. So I'll get rid of that because, again, that might be advanced. You might be covering that in your class, or you might not be. I don't know. I cover it in some of my classes, but not all. But the other really important thing to know here is the unit. And the units are joules, after James Prescott Joule. And we abbreviate it with a J. That's the basic introduction to work in terms of work, energy, power in that kind of a unit in a physics class.